Good. Now, please write the topic, mechanism of free radical halogenation. Okay. So in the last class, we started with free radical halogenation. And now, if I don't know whether you remember all this or not, but you have done this reaction in your 11th standard also. थोड़ा सा भी याद है किसी को? Aisha, Eliza?
So this one.
Yeah, this one.
Is it the cleavage part?
Which part?
Homolytic and hydrolytic cleavage?
Homolytic cleavage. Yes, you are remembering it correctly. It is homolytic cleavage. Also, if you look at the NCERT textbook, they have also referred that the hydrocarbons chapter. They have also referred the hydrocarbon chapter when they are going to explain the mechanism. Okay, but still, they're going to look at the mechanism in this class also. So when we have free radical halogenation, it is consisting of 3 steps. There is initiation, there is propagation, and then we have the termination step. Now let us look at the first step. Please write chain initiation. Before that, let us take a wait a second. Before that, let us take CH3, CH2, and CH3. Plus, let us suppose we have Br2 in the presence of UV light or sunlight, anything else, or HNu, anything you can write. You will get 2 products because here we have either this hydrogen can be replaced or this hydrogen can be replaced, right? CH3 or CH2, one of these hydrogen can be replaced. So I will get one of the product can be CH3, CH2, CH2Cl, and the other product would be CH3, CH3, and chlorine. First of all, write this down. Then is nobody see me? Now see. Now write the first step, that is chain initiation. In chain initiation, what happens? We have sorry. Oh yeah, my bad. Yeah. My bad. Sorry. This will be bromine. This will be also bromine. Yes, thank you for correcting that. Now we have bromine and bromine. In the presence of UV rays, this bromine and bromine bond, it will break homolytically. That means we have 2 electrons. One of the electron will go to this bromine, the other electron will go to this bromine, and we'll get Br free radical and another Br free radical. Now, chain initiation step, you can identify how. You can identify that here we don't have any radicals. In the reactant side, there is no radical. And in the product side, you have radicals. So wherever you see a reaction in which the reactant side does not have any radical, but the product side has a radical, that is the chain initiation step. Now, after this, you will all have the chain propagation step. Right, the next one, chain propagation. In chain propagation step, what is going to happen? One of the Br free radicals, it is going to attack on the CH3's hydrogen. If I look at the hydrogens here, I can write CH and CH2. Then I am writing this as the red hydrogen and this as the green hydrogen. There are only 2 types of hydrogens. Yes or no, please tell me. From the isomers, if you remember, we have 2 different types of hydrogens. The 2-degree carbon hydrogen and the 1-degree carbon hydrogen. Can you see that, Eliza and Asha? Any problem in that?
No, sir.
No problem, right? Now, the Br can attack any one of them. The Br free radical, it can attack either this one or it can attack this one, any one of them. So I am going to show them in separate cases. If the Br attacks on the red hydrogen, then in the red hydrogen, the product is going to look something like this. It attacks on the red hydrogen and it takes away the hydrogen, and you are going to get CH3 followed by CH with the free radical here, and CH3 is as it is. If it attacks on the green, one, then you are going to get CH3, CH2, and CH2 free radical. Any doubt till here? Yes or no? Please tell me. No doubts, right? And both of these are going to give you HBr and HBr in both the cases. Now, both of these reactions happen. It's not that Br will either attack on that red carbon, either attack on the red hydrogen or the green hydrogen. Both the attacks happen. But which one is faster? It depends on the stability of the product. If the red product is more stable, then we will be getting more and more of red products. If the green one is more stable, then we will be getting more and more of green products. And the reaction will proceed further through the major product will be formed by the one which is formed in the majority amount, which is more stable. So if you look at this is both of these are free radical, and the stability of free radical depends on, please see, free radical is like this now, both of them. See, it has 3 bonds and 1 free radical. 3 bonds and 1 electron. Can you see that, Aliza and Aisha?
Yes.
3 bonds. Okay, fine. Can you tell me what are the 3 bonds in the red one? In the red molecule, what are the 3 bonds? That carbon atom which is having free radical, it is having 3 bonds. What are those 3 bonds? Aisha, tell me. What are those 3 bonds?
CH3 and hydrogen.
Sorry?
CH3 and hydrogen.
Okay, so CH3 and hydrogen, that is 2 bonds, no? Third bond. Aliza, आप बताएं. Can you see that there are 3 bonds? Yes or no? Aliza?
Yes, sir.
Can you see the 3 bonds? Yes or no? जोर से बोलें, please. Can you see the 3 bonds, Aliza, in the red molecule?
Sir, पता नहीं.
अरे पता नहीं. अच्छा ठीक है, कोई बात नहीं. See, Aisha, what about you? Not very sure.
Hydrogen.
There is a hydrogen. See, now can you see the 3 bonds?
Yes.
Yes, Aliza.
Yes, sir.
है ना? तो उस हाइड्रोजन को हम साथ में लिख देते हैं, right? And when I write it like this, it does not mean, when I write it like this, no, CH, sorry, should be in red, CH, and when I make a bond like this, it does not mean hydrogen and carbon are bonded. Okay? It means carbon and carbon are bonded. Hydrogen is just as a branch here, and there is a free radical. Fine. Now, if an atom has 3 bonds, that means it has how many electrons? 1 electron, 2 electron. Each bond has 2 electrons, right? So it will be having 6 electrons from the bond, and one of the electron will be this free radical. That is equal to how many electrons? 7 electrons. Aliza and Aisha, any doubts in 7 electrons? Yes or no? Please tell me.
No, sir.
No doubt, right? Fine. Tell me, 7 electron is less than 8, and in order to be stable, a molecule, a carbon atom, or any atom, it should be at least having 8 electrons. Correct?
Yes.
So this is what I can say. Free radicals are electron deficient. Yes or no? Free
Yes.
radicals are electron deficient. And the CH3 molecules are going to give the electron density because they are plus I group. This is also plus I, this is also plus I. And since there are 2 plus I groups, what is going to happen? This is going to be 2 degree free radical. And what about this green one? Tell me. Primary, secondary, or tertiary? As you can see, it is only having 1 alkyl group, which is this one, which is giving it electron. That is why it is going to be 1 degree. And please write here like this. Here is a bracket missing. In free radical, 3 degree is more stable, then 2 degree, and then 1 degree. याद रहेगा? Yes or no, please tell me. याद रहेगा?
Yes, sir.
Okay. Now, which is more stable? Tell me. Red or the green one? Which is more stable, red or the green one? Those are going, please.
Red one.
Red one is more stable. If the red one is more stable, then the further reaction is going to happen through what? Through the red one only. Now, in chain propagation, you have to also see one more thing. In chain propagation, we have a free radical, that is Br. We have a Br free radical, and in the product, we are getting the carbon compound free radical. So in chain propagation step, in a reactant, you will have one free radical. In the product, you will get one free radical. And last, you have to write the chain termination step. Chain termination step. Please write this down. Chali, right next. In chain termination step, CH3, CH free radical, which is the most stable one, which will be formed in the majority amount, followed by you will have CH3 free radical, CH3. And again, a Br free radical will come here. It is going to attack, it is going to make a bond with this free radical like this. Both of these are going to interact with each other. There are 2 electrons. It is going to lead to formation of a bond, CH3, CH, Br, and CH3. Another, we have the green one also. The green one will be formed, but it will be in the minority amount. So you will get CH3, CH2, CH2 free radical, plus another Br free radical. Both of these are going to combine together and make CH3, CH2, CH2, and Br. So this will be major, and this will be minor. Please write this down. And then Aliza and Aisha.
Yes, sir.
Okay, so we'll write a note. Rate of free radical halogenation. Halogenation depends on the stability of carbon free radical. Carbon free radical. Okay, so right. The highest rate will be for benzyl, followed by allyl, followed by 3 degree, followed by 2 degree, and then followed by 1 degree. Now, benzyl and allyl, both of these are resonance stabilized. And 3 degree, 2 degree, 1 degree are plus I and hyperconjugation. From plus I and hyperconjugation. No write the question. Write the major products. For following. Write the major products for following. Write the question number 1. Please write the question. I will explain all of these. If you remember the topic, what is the topic? Free radical halogenation of Aliza and Aisha. Free radical halogenation of
It was mechanism of free radical.
हाँ, लेकिन ये टॉपिक जो चल रहा है पिछले क्लास से चल रहा है ना अलीजा.
Alkane.
Yes, Aisha, tell me free radical halogenation of
Alkane.
alkenes, right? क्या है? Alkenes है. Now, how will you identify that it is free radical halogenation? Halogenation का मतलब होता है reaction with halogen. What is the meaning of halogenation? So this is a halogen, this is a halogen, and this is a halogen. Please remember, if you see something like this, for example, it was not Cl2, but it was HBr. Please remember, this is not a halogen. What is this? This is a halogen acid. Yes or no, please tell me. Can you see the difference? Aliza and Aisha. So as you can see, first of all, you will see the reagent that all of these are halogen. And how will you identify that this is halogenation? How it is free radical halogenation? You will look at the arrow. You see H nu, it is representing photons, that means light. Sunlight, it means it is representing sunlight. UV rays, it is also a kind of electromagnetic radiation, that is light. So this is a free radical halogenation. If you remember the letter helper. Can all of you see that? Yes or no? Please tell me, Aliza and Aisha.
Yes, sir.
Now let us move on to the products. Now, whenever there is a reaction with alkene, then in the benzene ring, we have only 2 carbons which are alkane carbon. That means which are sp3 hybridized. It is the green one and it is the red one. Correct? Yes or no? Please tell me. Aliza and Aisha. And both of these are different. Yes or no? Please don't write anything now. Please keep your pen aside if you have written 1, 2, 3 questions. Aliza and Aisha, you have written 1, 2, 3 questions.
Yes, sir.
Yes, sir.
Keep your pen aside. Turn your mic on. Okay. In the first question, Aisha, turn your mic on. In the first question, there are 2 different carbon atoms, and only those 2 are alkenes. That means they are sp3. Otherwise, all of them are having what? Double bonds. That means they are sp hybridized. And
Yes,
next thing, tell me, both of these carbons are different or same?
different.
Different. Okay. Now tell me how many sp3 carbons are present in the second structure?
No.
How many, Aisha?
Could you repeat?
How many sp3 hybridized carbon atoms are present in the second structure?
4.
4. Aliza, can you identify? Aliza,
Yes, sir.
can you tell me how many or no?
Yes, sir. 4, I think.
Which 4? Tell me.
Okay. 1, 6, 5, 4.
Okay. Now, are all of these 4 carbon atoms same, or some of them are, or all of them are different, or some of them are same? The ones
In
you
the second
identified as sp3, All of them are different or some of them are same? Aliza and Aisha?
So
सारे different है या कोई same भी है उसमें?
सर वो 4 या 6?
इन चारों में 1 2 3 4 में
2 and 3 are same.
2 and 3 are same. अलीजा आपको दिख रहा है 2 3 सेम है?
यस सर।
अच्छा, दूसरी बात अलीजा, आपने पिछले हफ्ते वाली रिकॉर्डिंग देखी अभी तक या वो नहीं देखा अभी तक आपने?
सर रिकॉर्डिंग वाले सेक्शन में भी वो आ रहा है नॉट अवेलेबल, तो आई विल टॉक टू
अरे
देम
भाई
टुडे।
देखिए सुनिए, लेना ही देना नहीं है आपको। आपके पास नंबर है लर्निवियो का?
यस सर।
आपने कितनी बार कॉल किया उनको कि हमको रिकॉर्डिंग भेजिए, हमको रिकॉर्डिंग भेजिए, हमको पढ़ना है?
नहीं किया अभी।
एक बार भी नहीं किया तो फिर कैसे चलेगा काम? ठीक है, वो रिकॉर्डिंग है, ठीक है ना?
ओके।
आप ऐप में मत ढूंढिए, नहीं मिले आपको आप मैसेज कर दीजिए, ठीक है लर्निवियो को?
ओके
1 घंटे
सर।
में रिप्लाई नहीं आए फिर कॉल कर दीजिए।
ओके।
फिर बोले अच्छा ठीक है हम भेज रहे, फिर नहीं आए फिर कॉल कर दीजिए, ठीक है? परेशान कर दीजिए। ओके अलीसा?
ओके सर।
ठीक, चलिए 1 2 3 4 में बताइए। आप उनको नहीं परेशान कीजिएगा तो फिर आप हमको परेशान कीजिएगा,
नो
आपको
सर, आई
याद
डू
नहीं
इट
रहेगा।
टुडे। सर आज ही
हाँ
परेशान
वेरी
करेंगे।
गुड। So 2 and 3 are same, Aisha, and 1 and 4 are also same. Yes or no?
Yes, sir.
Okay. 1 and 4 are also same. Now, if you look at the one carbon atom, it is sp3, correct?
Yes.
It is connected to sp2, correct?
Yes.
So it is allyl carbon, if you remember. Allyl has a fragment like this, right? C double bond C,
Yeah.
and then we have the C. So sp3 further connected to sp2, right?
Yes, sir.
So rather than, so what will be my major product? As I said, the rate of reaction, benzyl and then allyl. Now in this case, I have how many carbons? 1, 2, 3, and 4. So even though second carbon and third carbon, both of them are same, and they can also do the reaction, but they will be formed in the minor amount. The major product here, it will be this one. Similarly, in the benzyl one, if you see, the green carbon is the benzyl carbon, right? The sp3 carbon, which is further attached with a benzene ring. So that benzyl carbon will undergo halogenation more quickly than the red carbon atom. So I will get the Br in this carbon. Now, if you look at the third structure, now in the third structure, we have how many? See, we have this, both of these are same carbon atoms. Then this one is different. Then we have the blue one. This is a different carbon atom, and then this is a different carbon atom. So in total, we will be having 1, 2, 3, 4 products. But which will be major? So please tell me, the red one is 1 degree, right? The green one is what degree? Tell me.
2 degree.
3 degree. The blue one is?
2 degree.
Blue one. Blue one is? देख के बताएं Aisha, blue one is?
1
Look at
degree.
that. 1 degree. Tell me now, blue one is connected to how many carbon atom? Aisha, keep your mic on. आप off क्यों रख रही? Mic on रहना चाहिए, जब हम off करने बोले तब off कर लीजिए, ठीक है? अभी on रहना चाहिए. Please don't turn it off always. The blue carbon is connected to how many carbons?
2.
How many?
2.
To what degree?
2 degree.
आप 2 degree बोल रहे थे, 1 degree बोल रहे थे?
I said 1 before.
You said 1 before, ठीक है. So this is 2 degree. What about the white one?
1 degree.
Which will be fastest? Tell me. कहाँ पे Br कहाँ attach होना चाहेगा? Here ना, we have given the rate, right? 3 degree में attach होना चाहेगा, ठीक है? So you'll make the product as it is and attach a Br on the 3 degree carbon. That's it. Please write the products. All of these are major products, okay? Done. Should I move on? Aliza and Aisha done?
Yes, sir.
Yes, sir.
Okay, right, next. Now see this carbon atom. What will be the formula of this this molecule? Tell me, guys. What will be the formula of this molecule? How many carbons? How many carbons?
Five.
How many carbons? जोर से बोले आयशा, बहुत धीमी आवाज आ रही है.
Five.
5.
5 carbons. Thank you very much, Aisha. How many hydrogens?
12.
12.
If you do bromination, chlorination, or anything else, any halogenation, free radical halogenation, then what can I write here? Sunlight. Now tell me, how many different carbon atoms do we have? हमारे पास 5 carbon atoms है, right?
Yes, sir.
4 of them are same.
Yes.
That means I will get, and only those 4 are having hydrogens जहाँ से hydrogen replace किया जा सकता है, right?
Yes.
I can make only one monobromo compound, and that monobromo compound is going to be CH3 carbon, CH2 Br, and the other carbon atoms will have CH3 and this CH3. So I can get only one product, one monobromo product. There is no other product possible, even though the formula is C5H12. So you can get a question like this. Identify the alkane with formula C5H12 which gives only one monochloro product on photochlorination. ठीक है? So I hope you understand the question. देखिए, reaction देखने के बाद सवाल आसान लगेगा. Identify the alkane with formula C5H12 which gives only one monochloro. अभी यहाँ पे हमने bromination किया है. They are asking about monochloro. This is monobromo product. Monobromo मतलब I hope all of you remember mono means one halogen, है ना? And one bromine is attached. So it is monobromo product, है ना? Monohaloalkanes, dihaloalkanes, and trihaloalkanes. We have done this in the first class itself. A monochloro product on photochlorination. What does photochlorination means? You're doing chlorination. That means you're reacting it with Cl2 in the presence of sunlight, and sunlight is written as photo. Understood, Aisha and Aliza?
Yes, sir.
Yes, sir.
Okay. Okay. So you'll write this molecule. What is the name of this molecule? What is the name of this molecule? देखिए इसके दो नाम हैं, ठीक है? एक तो आपके पास IUPAC नेम आ जाएगा किस तरह से? You'll have 2,2 dimethyl propane. This is the IUPAC name. Another is going to be the common name, that is neopentane. Okay, that is neopentane. Please write this down.
So what about the bromine?
Sorry.
We don't mention bromine.
Achha. I'm not saying that. I'm saying that this is the name for this molecule. They're asking you to identify the alkane. Na?
Okay.
Got it?
Yes.
For this, the name is going to be 1-bromo 2,2 dimethyl propane. ठीक है? Should I move on? आगे
Yes.
बढ़े चलिए. Right, next question. Identify the number of monochloro products formed by the photochlorination of CH3 whole twice. Then you write CH, CH2, CH3, CH, CH2, CH3. Can both of you make the structure of this one and tell me how many monochloro? You just need to predict how many different carbon atoms are there. जितने अलग-अलग carbon atoms होंगे, जितने different types के carbon atoms होंगे, you will get that many monochloro products. First of all, try making the structure. Send the. Both of you have phone, Aliza and Aisha, or no?
Yes, sir.
Yes.
Aisha, आपके पास है? Both of you have my number or not? आपके पास मेरा number है?
No,
Yes, sir.
अच्छा, Aliza लिख लीजिए.
Yes, sir.
And once you are done making the structure, I will give you 1 minute. Please send me on WhatsApp. 2 मिनट WhatsApp में नंबर आपको ऐड करने में टाइम लग जाएगा. ठीक है? So you have 2 minutes. Draw the structure and send it to me on WhatsApp. Okay, Aisha, your structure is fine. Aliza, आपके structure में दिक्कत है.
सर वो CH के ऊपर है किसी वस्तु.
क्या?
नहीं. सर किधर गलत है?
किधर गलत है? स्ट्रक्चर पूरा गलत है। स्ट्रक्चर किधर से ना गलत होगा, स्ट्रक्चर तो फिर पूरा गलत हो जाएगा ना।
नहीं हाँ
ठीक है, अब देखिए साथ साथ बनाएंगे अलीजा।
सर CH के ऊपर CH3 आएगा सर।
हाँ हाँ, वो हमें दिख रहा है, हमने चश्मा लगाया हुआ है, हमको चश्मा लगा हुआ है, लेकिन चश्मा हमने लगाया हुआ है। ठीक है, अब देखिए। ओके अलीजा,
ओके ओके।
ठीक है। आप ब्रांचेस को मत लिखिएगा, पहले आप किसको लिखिए जो ब्रांच के साथ नहीं है। व्हाट आर नॉट इन ब्रांचेस? वी हैव CH। अच्छा, जस्ट अ सेकंड, आयशा आप आगे कर सकती हैं? कैन यू आइडेंटिफाई हाउ मेनी डिफरेंट टाइप्स ऑफ कार्बन एटम्स आर देयर एंड टेल मी हाउ मेनी डिफरेंट टाइप्स ऑफ हाउ मेनी डिफरेंट प्रोडक्ट्स वी आर गोइंग टू गेट?
4.
यू कैन डू दैट राइट? अच्छा ठीक है, आपने आंसर बता दिया। ओके ओके फाइन। सी हियर अलीसा, हमने लिखा CH, देन आई विल राइट CH2, then I will write CH3. Now here we have CH3 twice. Yes or no?
Yes.
That means we have two branches. Brackets jitne hai na? So we have two branches and both have CH3. Both have CH3. Okay. Assalamu alaikum Maryam, how are you? मरियम, आप सब कुछ तो ठीक है बट आप लेट बहुत ज्यादा हैं, कैसे चलेगा? सॉरी सर तक आया फिर माइक ऑफ हो गया। यस मरियम, व्हाट हैपेंड? Alisa, you see here, can you see that this one carbon and one carbon, both of these carbons are same? Yes or no?
Yes sir.
The second one is different.
Yes.
Third one is different.
Yes.
And then I can say this fourth one is also different.
Yes.
If, oh, wait a second, this will be CH3, my bad. This will not be CH2, this will be CH3. Achha, tell me, why am I not seeing that this CH3 and this CH3 are same? Kya same nahi hai dono?
No sir.
Why it is not same? Tell me.
Sir, because that CH3 is connected to a carbon which is, is connected to a 2-degree carbon.
Which carbon is connected to a 2-degree carbon? Fourth wala ya one wala?
One wala.
One wala to 3 degree hai na?
अच्छा हाँ, sorry. One वाला 3 degree और 4 वाला 2 degree है.
2 degree है, ठीक है. So that is why we are going to get how many products? We are going to get 4 different products, है ना? And let us try to make the products also once we have done mono chlorination. So achha, let me have these numbers as red only because I will make the products in those colors. So for the red one, I will add Br, which is added to this will be having CH2. Actually, I really love this bond line structures. I have 1, 2, 3, 4 carbon atoms, and here I have a CH3 which is further attached with Br. Problem hai kya Aliza, Aisha, and Maryam in this structure?
No sir.
No problem. Aisha, a problem is
No,
structure
sir.
mein? No problem.
No, sir.
So I will make these bond line structures only. And then the green one will be, this is the same structure, and the green one will just have a Br. Oh, nahi, my bad. क्लोरीनेशन कर रहे हैं ना, हम भूल जाते इन सब चीजों को, थोड़ा सा हमें ना याद दिला दीजिएगा सर, क्लोरीनेशन कर रहे हैं, ब्रोमिनेशन कर रहे हैं, ठीक है? आई समटाइम्स फॉरगेट दिस, है ना, याद नहीं रहता. क्लोरीनेशन कर रहे हैं. सो सेकंड कार्बन एटम, third one will be 1, 2, 3, 4, and this third carbon atom will have chlorine, and then fourth 1, 2, 3, 4, this fourth one will have chlorine, and the structure is as it is. A fourth wala white hai, so I should make it white. Done everyone?
Yes.
Can I move on? This was one of the major topics जो method of preparation में उससे सवाल आते हैं, ठीक है ना? This big topic. Right, next, by electrophilic aromatic substitution. एक सेकंड जरा रुक जाइए. Let me see the number. First, I guess second number. So from हाइड्रोकार्बन्स, उसमें हम लोग नेक्स्ट क्या करने वाले हैं, बाई इलेक्ट्रोफिलिक aromatic substitution. Now, in your 11th standard, you have already done the chlorination, bromination of benzene ring. This is the same reaction. Plus Cl2 in the presence of a catalyst. You can use AlCl3 or FeCl3. You can use AlCl3 or FeCl3. Which is going to give you 1 chlorine here. Now, similarly, if you have Br, then Br2, you can have AlBr3, FeBr3, or even Fe works here because Fe reacts with Br2 and then forms the catalyst in C2. So it is going to give you, this is Br. Let me write, this is chlorobenzene. This will be, tell me what will be the name of this compound. I hope you can write this down. Yes or no?
Yes.
है ना, हो जाएगा bromobenzene हो जाएगा, chlorobenzene और हो जाएगा bromobenzene. Now, if I have a substituted benzene, for example, I have CH3 group, then we have to look whether it is a electron donating group or withdrawing group. Now, since CH3 is an electron donating group, it is going to give you products in the ortho and the para position. You will get CH3 as it is. The chlorine will attach on this ortho position. Plus, you will get another product. CH3 and chlorine in the para position. Now, in this case, this will be major product. Let me write the name here. This is O-chloro. CH3 attached with benzene is known as toluene. Toluene. And this will be p-chlorotoluene. P means para. Similarly, if you have any electron withdrawing group such as NO2, this is nitrobenzene, plus let us suppose we are adding Br2 in the presence of Fe. This NO2 will be as it is, and here you will get the Br. So this is M bromo nitrobenzene. ठीक है, write a note. Electron donating groups. What are the electron donating groups? Any alkyl group, CH3, C2H5, anything, R, represented by R. ठीक है. Electron donating groups are R, then you will have OH, then NH3. अच्छा, ये कुछ याद आ रहा है आपको? इलेक्ट्रॉन डोनेटिंग ग्रुप, इलेक्ट्रॉन विथड्रॉइंग ग्रुप फ्रॉम 11th स्टैंडर्ड, या याद भी नहीं आ रहा है? नाम याद आ रहा है, नहीं आ रहा है? याद है? ओके. देन यू हैव OCH3 की जगह लेट मी राइट OR, है ना? Any alkoxy group is present, etc. These will when attached to benzene, they give ortho and para products on halogenation. Next लिखिएगा. If you have electron withdrawing group, such as we have written one, that is NO2. CHO, C double bond O, and attached to something else. C double bond O, OH, C double bond O. You can have NH2, C double bond O, OR, etc. When attached to benzene ring, to benzene, they give only meta product. On halogenation. So please write this down. Right, in hydrocarbons, we have the third method. From alkenes. Right here. When alkenes are treated with halogen, alkenes are treated with halogen. Whenever I write halogen, please understand it is F2, Br2, Cl2, I2, and all of these. HBr वगैरह halogen नहीं. Those are halogen acids. Halogen, they form vicinal dihalides. What is the meaning of vicinal dihalides? PC. C double bond C. Now these carbon atoms will have some groups here and here. Now, if I react this with X2, halogen atom, then these white one, that means all the groups attached on the carbon atom will be same, and only new bond, that is X and X, will be formed after the breaking of pi bond. See what is happening here? Whenever you see a reaction, the very basic understanding of a reaction is what bond is broken and what bond is formed. So the bond that is broken here is the pi bond has been broken, and two new single bond has been formed. And as you can see, both of the halogen atoms are adjacent to each other. They are neighbor to each other. That is why they are known as vicinal dihalide. Vicinity se aaya hai. Vicinity means in neighbor. So it is known as vicinal di. Di means two halides, means there are two halogen atoms. So it is vicinal dihalides. Right, next. Write a note. Bromination is used as a test for unsaturation. Unsaturation, the simple matlab presence of a pi bond, है ना? Presence of double or triple bond. So if you have a double bond, let us suppose I have CH2, double bond CH2. I will treat with this Br2. I will treat this with Br2. Now Br2 is brick red in color or brown in color, है ना? I just forgot if it is brick red or it is brownish. काफी ज़्यादा similar होता है color, brownish and brick red. Br2 COMOUR. It is deep red, brownish red. तो वही लगभग ठीक है, brownish red color. Fine. So this is brownish red. But when Br2 reacts with any alkene, it forms CH2. This will get a Br, single bond CH2. This will get a Br. Now, since bromine is not remaining in the reaction, then what is going to happen? Bromine khatam ho gaya. So this is no color. What I can say now? Alkenes decolorize bromine water. Okay. So if you have bromine water, if you want to test if a sample is having double bond or not, then what you are going to do? You're going to add a small amount of Br2. And as soon as you add a small amount of Br2, and that, what happens? The brownish red color disappears. That means the sample had double bond. Then everyone, yes or no, please tell me. All of you done, yes or no?
Yes, sir.
Yes. Done. Take actually. No. Write the products for following. फर्स्ट टू कीजिएगा, ठीक है, थर्ड भी कीजिएगा, और थर्ड और फोर्थ में देखिए देयर इज अ स्लाइट डिफरेंस. Then Aliza, Aisha, Mariam तो खैर बहुत लेट आई थी. I don't know whether she will understand clear or not. Yes, Aliza and Aisha done. फर्स्ट टू हुआ कि नहीं बताइए. Aliza and Aisha.
Yes, sir.
Aliza, what about you?
No, sir.
Aisha, अच्छा, Aliza आपको दिक्कत हो रही है?
सर अभी समझ आया.
अभी समझ आया, ठीक है. Aisha, can you send the answers on my WhatsApp? मरियम, अगर आपने भी किया है ना, तो मरियम, can you please send the answers on my WhatsApp? Sorry, I did not hear something. Someone was saying something. Aliza, once you're done, send the answers, okay? यस, व्हाट अबाउट द अदर? बाकी किया आपने या फिर सिर्फ फर्स्ट टू किया है आपने? आयशा?
Sir, I'll do the two now.
अदर टू आल्सो। अलीजा, एक भी हुआ? यस अलीजा।
सर नहीं।
नहीं, ठीक है। क्या करना है जरा बताइए। डबल बॉन्ड हटाना है। यस अलीजा, कैन
यस
यू सी
सर।
व्हाट इज हैपनिंग? कैन यू सी व्हाट
यस सर।
इज हैपनिंग? व्हाट इज द चेंज हियर इन द रिएक्शन? आपके पास x2 है। x2 का मतलब क्या हुआ? व्हाट इज द मीनिंग ऑफ x2?
मतलब
x मींस,
हाइड्रोजन।
हाँ, x मींस हैलोजन। वेरी गुड। व्हेन हैलोजन इज अटैकिंग एल्कीन, एल्कीन दिखना है आपको। एल्कीन प्रेजेंट है, डबल बॉन्ड है। व्हाट इज हैपनिंग? द डबल बॉन्ड इज ब्रेकिंग। 5 बॉन्ड टूट गया ना, डबल से सिंगल हो गया।
यस
डबल
सर।
से क्या हो गया? सिंगल हो गया।
सिंगल।
और फिर क्या हुआ? द कार्बन्स व्हिच हैड डबल बॉन्ड, उसमें क्या लग गया? व्हाट इज अटैच्ड
हाइड्रोजन।
देयर? हैलोजन। ठीक है, आप सबसे पहले इसमें बनाइए, डबल बॉन्ड छोड़ के सब पूरा स्ट्रक्चर बनाइए इसका। कैन यू मेक दैट?
यस सर।
ठीक है, एंड मार्क द कार्बन एटम्स व्हिच हैड डबल बॉन्ड। वो करके हमको भेजिए आप। सेंड मी द फोटो। ठीक है, अब उन दो कार्बन्स में क्या लग जाएगा लीजा? टेल मी।
हाइड्रोजन ब्रोमीन।
व्हाट हाइड्रोजन?
ब्रोमीन।
समझ में आ गया कैसे करना है?
अच्छा अच्छा अच्छा। ओके ओके।
हो गया?
हम्म।
ठीक है, ना आप कर लीजिएगा। लिसन टू द थर्ड एंड फोर्थ वन। थर्ड एंड फोर्थ में क्या डिफरेंस है? टेल मी। आयशा बताएं, व्हाट इज द डिफरेंस इन द थर्ड एंड द फोर्थ वन?
Fourth वाले में H नहीं होना.
फोर्थ वाले में H नहीं है, दैट मींस इट इज halogenation. It is halogenation, but it is halogenation. What kind of halogenation? Free radical halogenation, right? ये वाला हम लोगों ने आज किया ही है, right? And in this case, you know that what is going to happen? The alkene में कुछ नहीं होने वाला है, यहाँ पे
Sir,
रिएक्शन
मैंने
होगा, right?
आंसर भेजा है.
हाँ हाँ, आपने आंसर भेजा है?
Yes sir.
अच्छा, नहीं नहीं नहीं, ओके, नहीं थर्ड वाला, नहीं 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 नहीं, उसमें देखिए, सी, इसमें हालोजिनेशन होगा, फ्री रेडिकल हालोजिनेशन, एंड द एल्कीन इज द रिएक्टिव साइट, करेक्ट? तो या तो
Yes.
रिएक्शन इस ग्रीन वाले कार्बन पे होगा, और द रिएक्शन इज गोइंग टू हैपन ऑन दिस रेड कार्बन एटम, करेक्ट? नहीं,
Yes sir.
कैन यू सी, वी हैव डन दिस नाउ। देखिए सेम चीज है, सेम
Yes
थिंग
sir.
वी हैव डन। ठीक है, बस वहां बी आर है, यहाँ पे सीएल, पहले सीएल टू था, अब ये बी आर है, सीएल टू। सो आई विल रादर गेट व्हाट, प्रोडक्ट लाइक दिस। In this case, and in this case I will be getting something over here. इसको ऐसे बना देते हैं, करेक्ट? yes or no, please tell me all of you.
Yes sir.
ठीक है, प्लीज राइट डाउन द प्रोडक्ट। अलीजा, आपका बाकी ठीक पता, सेकंड एंड थर्ड?
सर
अलीजा?
मतलब हाँ।
हाँ,
यस सर।
पक्की बात?
पक्की बात।
ओके, ठीक है, प्लीज कॉपी दिस डाउन, लेट मी नो once you're done, and that's it for today. Next we will be looking at reaction using hydrogen halides, ठीक है, and that is also one of the important. Assalamu alaikum Saad, how are you?
Walaikum salam, sir. Alhamdulillah, sir. I'm good.
Okay. We'll start and you have to wait 5 more minutes. Okay, sir? Then we will start.
Yes, sir. Okay.
बाकी अलीजा, आयशा, मरियम हो गया आप लोगों का?
Yes, sir.
Sir, can you
जी
explain
बताएं।
the fourth one?
हम नहीं एक्सप्लेन करेंगे फोर्थ वन।
नहीं।
क्यों नहीं करेंगे हम बताइए? यानी कि पहले किया हुआ होगा।
Yes, sir.
कहाँ किया? देखिए इस तरह का रिएक्शन कहीं दिख रहा है? ऐसे आपके पास ऐसे एकदम सेम है, ठीक है। अब
Yes.
Br2 लगा हुआ है, उसके बाद सनलाइट होगा या फिर HNO होगा और इस तरह का प्रोडक्ट मिल रहा होगा। कैन यू सी दैट इन द नोट्स? आज के ही नोट्स में है।
हाँ सर, वो तो दिख गया।
वो तो दिख गया। याद कीजिए फिर क्या एक्सप्लेनेशन क्या था दिस वन। ये वाला है ना?
Yes,
इसमें हमने
sir.
क्या बोला था? पहले फाइंड आउट, पहले देखिए कि कौन सा रिएक्शन हो रहा है। हाउ विल यू सी दैट? विल सी दैट हैलोजिनेशन इज हैपनिंग, है ना? एंड
Yes,
व्हाट
sir.
टाइप ऑफ हैलोजिनेशन? फ्री रेडिकल हैलोजिनेशन, बिकॉज इट इज सनलाइट। करेक्ट अलीजा?
Yes, sir.
एंड व्हेनेवर देयर इज अ फ्री रेडिकल हैलोजिनेशन, तो किसका होता है फ्री रेडिकल हैलोजिनेशन ऑफ? क्या टॉपिक था लास्ट क्लास में?
Alkene.
एल
Alkene.
ANE, राइट?
Alkane.
हाँ, एल्केन, या करेक्ट। सो एल्केन यहाँ पे क्या क्या है? दिस इज एन एल्केन एंड